already 7. Should we start?
Yeah, I think we should.
Okay. So good evening, all the members, Professor Aluwalia sir, Ranjita Das Deka madam, and all other Mr. Neelesh sir, and all the distinguished members. In the starting, on behalf of NASNI, I would like to pay sincere tributes to great visionary scientist, Professor Jayant Narlikar ji. His sudden demise is an irreparable loss to the nation. He was a great researcher and teacher of physics and a very profound communicator also. Our sincere condolences to the bereaved members of the family of Professor Narlikar sir. Om Shanti. Now I will request Mr. Ritesh to take over the stage to start the session of NASNI for today. Mr. Ritesh.
Thank you, sir. So, good evening to all. Today we gather here to pay tribute to one of the most brilliant mind of modern India, Professor Jayant Vishnu Narlikar, a visionary astrophysicist, a dedicated science communicator, and above all, a true son of India who inspired generations to think scientifically and question fearlessly. In his memory, I would like to share a heartfelt reflection in his own words, a glimpse into his early life, influences, and dreams for a scientifically awakened society. From Jayant Narlikar. My father was a mathematician and my mother was a Sanskrit scholar. It was my mother who taught me and my brother Sanskrit and taught us a deep love for its literature. She took a keen interest in our studies and made us what we become. My mother teaching are the basis of our existence. I spent my childhood in the beautiful surroundings of Banaras Hindu University, where my father taught. It was a beautiful place indeed. It is still beautiful to look at and live in. But in the 50s, the academic environment here was not corrupt. My father was a mathematician and my mother was a Sanskrit scholar, but she did not teach in the university, though she was a postgraduate in Sanskrit from Mumbai University. It was she who taught me and my brother Sanskrit and taught us a deep love for its literature. She took a keen interest in our studies and made us what we become. After completing my BSc from Banaras Hindu University, I went to Cambridge at the age of 19 to study higher mathematics. My first goal was mathematics, but there you are asked to choose from different branches of mathematics. I found particularly astronomy applications very interesting. The lectures were very good. At that time, I also read a book by Fred Hoyle called Frontiers of Astronomy, which gave a very readable descriptions of what was happening in astronomy. All these things inspired me to go into astronomy research. In Cambridge, astronomy is treated as a branch of mathematics, so I chose it. I have always stressed the need to develop a science culture in our society. Today, planetariums are found in major cities of India. I have seen the growth or spread of planetariums as I grew up. I remember the first planetarium was built in Kolkata, and it was the only planetarium for some years, until a planetarium came up in Bombay, now called Mumbai. Now there are a series of planetariums in many cities of our country. These planetariums have a great role to play in promoting the culture of science if they work properly. By which I mean that there are a lot of superstitions related to astrology in India, where people believe that the position of stars and planets control a person's destiny. These baseless claims must be refuted. This is where planetariums can help. They should also be used to tell people what is happening around us, not only in the universe, but also highlighting the many new scientific discoveries around us. There is a lot being discovered here on Earth, and some of these should be incorporated in planetarium programs. I'm very optimistic about the younger generation, at least the school-going children's. They seem to be much more curious than the generations before them. They also seem to be aware of scientific discoveries and advancements happening around them, even if they do not fully understand the science of it. We should use their curiosity and let them know. This way, they will be encouraged to ask the right kind of questions, and eventually they will turn into a very knowledgeable group. An excerpt from autobiography of Padma Vibhushan awardee astrophysicist Jayant Narlikar. He passed away on Monday, 20th May 2025. So now I would like to come back on our today's Wednesday talk. Myself Ritish, and I am delighted to host today's session once again. Professor P.K. Aluwalia and Professor Hemant gave me this opportunity to host this NASNI Wednesday talk once again. A very warm welcome to all the participants and a special welcome to our respected guest, Professor P.K. Aluwalia, President of the Indian Association of Physics Teacher. We are truly delighted to have you with us. It's great to see such enthusiastic participation continuing in our 9th meeting. As always, we aim to bring together curious minds and foster meaningful discussions through these talks. Thank you for joining us today, and let's start with an engaging and insightful sessions. But before we begin, since we have some new participants, so please allow me to take a few moments to introduce what NASNI is. NASNI stands for National Astronomy Network of IAPT. NASNI is a dedicated platform under the Indian Association of Physics Teacher, designed to foster interest and engagement in astronomy and sky watching among students, educators, and general public. Why was NASNI created? So to bridge the gap between new sky gazers and expert by providing structured learning, mentorship, and observational guidance in astronomy and astrophysics, NASNI has been created. It aimed to nurture curiosity, promote a scientific temper, and connect enthusiasts with leading astronomers and experienced by sky watchers. How does NASNI operates? It organizes workshops, lectures, and observational sessions for beginners and enthusiasts. NASNI also facilitates interactions with professional astronomers from planetariums, research institutions, and academia. It encourages community participation through sky watching camps, online discussions, and field observations. Additionally, it supports school and college students in astronomy projects, competitions, and research endeavors. In the next 6 months, NASNI has an exciting agenda. It plans to conduct both introductory and advanced courses on sky gauging and telescope handling, organize a national level observational challenge, set up regional astronomy clubs to strengthen grassroots participations, and host a public lecture series featuring prominent astrophysicists and science communicators. Through these efforts, NASNI envisions creating a vibrant ecosystem where individuals can gain hands-on experiences, they can interact with experts, they can access structured learning paths, and contribute meaningfully to citizen science and real astronomical research. Now, how does NASNI wish to grow in future? Looking ahead, NASNI aims to expand its reach by establishing local astronomy hubs in schools and colleges, and developing mentorships program. It also seeks to partner with planetariums, research institutes, and observatories and promote collaborative amateur projects that can lead to scientific discoveries. Now, continuing this mission of outreach and engagement, the IAPT through NASNI organizes talks like today's talk on first and third Wednesday of every month. So these sessions are aimed at building a strong national community of astronomy learners and enthusiasts. Following that tradition, today event has been organized to continue that effort. And we are grateful to have such an engaging session line up for all of us. It is my pleasure to introduce our today's speaker, Engineer Neelesh Rana. He is a passionate science communicator and dedicated amateur astronomer, actively involved in the field since 2000. He holds a Bachelor of Engineering in Electrical Engineering from Ali College of Engineering, Morbi, Gujarat, completed in 2001. Currently, he serves as the project coordinator at the Shri Ovi Seth Regional Community Science Center in Rajkot, Gujarat. He is also the founder and convener of the Big Bang Astronomy Club at the same center, a platform that continues to spark scientific curiosity among students and enthusiasts alike. Beyond astronomy, he is a licensed amateur radio operator with a call signature VU3IUD that he will uh, like, talk about, reflecting his broad interest in science and communications. We are truly honored to have him with us today to share his insights and experiences. Please join me in warmly welcoming Neelesh Rana. Thank you.
Should I share my presentation?
Yes,
Yes,
sir.
please.
Yes, sir. You can share. It is visible, sir. Maximize कर लीजिए.
Okay, is it visible in full screen now?
Yes, sir.
Okay.
It is visible.
So thank you very much for a very good introduction. It is an honor for me to talk to such a distinguished lot, and I thank all the distinguished people who are present in this meet. And I would like to share today something which I have enjoyed through this quarter of a century of my journey into the field of amateur astronomy. It all started on one fine day back in 2000 when I saw some program on sky watching, the National Geographic Channel, and that got me hooked into it. Uh, so the title of my talk today is The Joy of Sky Watching, and it is an introduction to amateur astronomy. I think astronomy as such is the only science which anyone can pursue as an hobby. One cannot say that physics or chemistry or biology or maybe botany is my hobby, but he can say that astronomy is my hobby. So let me start by introducing my institute as such, or I should rather say a subset of my institute, that is the Big Bang Astronomy Club, which is a part of Shri Ovi Shet Regional Community Science Center. This is a science center which is uh, catalyzed and supported by GUJCOST, that is Gujarat Council on Science and Technology, that comes under Department of Science and Technology of the Gujarat State Government. And the club has been running at our center since last 22 years, or So it was established on an annular solar eclipse day, and it was just a coincidence that the day that we uh, gathered together to watch a solar eclipse, and the idea sprang that we should open an astronomy club at our center, and thus it was established on this 31st of May of 2003. It is today one of the largest astronomy clubs in the country. We have about 70 plus permanent members, and about 3,500 plus people are connected with us directly via social media, and that is mostly WhatsApp. So if we put out a message regarding any skygazing program, that immediately reaches about 3,500 people in a flash. So that is a, a good number, I might say, that we are able to disseminate this scientific acumen to so many people as such. The Big Bang Astronomy Club, I think, is responsible for showing the skies through our telescopes to about 2,75,000 people and counting. And it is growing ever stronger, and we would try to achieve much more than this. As far as the equipment goes, the Big Bang Astronomy Club has about 22 plus telescopes of varying size, multiple binocular pair. We have a very advanced astrophoto setup, a dedicated with dedicated astro cameras and such other auxiliary equipment. And presently, Big Bang Astronomy Club has got its own observatory, which we'll talk about in the last part of this talk. Uh, and we have a very large experienced volunteer base. These are many people who have been connected to us since last many years and are quite proficient with the use of telescope, or may it come that in dissemination of astronomical knowledge about astronomical phenomena to common public. So presently, this is the thing that plagues the new generation as such. Their life has been zoomed into a screen which is 4.5 to 5.5 or maybe 6.5 inches across. And most of the time, you will see that people are sitting somewhere, walking, or even driving, and they are engaged in their phones. So, this is the present scenario of I might say each and every generation as such. It's now not limited to the young people only, but this is basically a distraction which is something that we must look into. So I might suggest that when was the last time when someone looked up at the night sky, uh, a beautiful night sky from a beautiful dark location where you can see the band of the Milky Way, and that would be something to
Right.
cherish. So when you look at such a beautiful sky that is full of stars, you see the band of our Milky Way going from one end of the sky to the other end of the sky, the summer Milky Way, and it is something enchanting to look at. You cannot take your eyes off it. But when looking at this spectacle, any person who is, let us say, an educated person to a certain aspect, what are the three lessons that we might learn when we look at the universe from our vantage point of or from our perspective? The first one definitely would be how tiny we are, how small we are, how inconspicuous we are when we look at the universe. Let us go into the detail of that. So this is what our planet looks when we are, say, about 200 or 300 kilometers away from it. I think from this image, there doesn't seem anything extraordinary about our planet. The sheer size of our planet does not highlight anything that has been humanly achieved. So from looking at this photograph, we cannot say that anything like a human race would have been on this planet. Of course, if we take a look at the earth at the night, we might able to see the lights of our cities, and that might give away the human development or human technology. But during daytime, we are not at all visible even from 200 to 300 kilometers across. Now this is our planet. Diameter is about 12,000 odd kilometers. Our history, maybe 2000 years, 4000 years, all our conflicts, all our wars, they have been on this small sphere, and nothing about us exists even at 150, 200, or 300 kilometers away from us. Let us go further away from it. Of course, this is a made up photograph of our solar system, but the sizes of the planets and our sun are in just right proportion. And here we have our earth. You can see how insignificant it is when we compare it to, say, Jupiter or Saturn. uh, Sun is not even able to fill the frame or i- in the frame of our picture, so it is that large when compared to the planets of the solar system. So this is our existence. Everything that we have achieved is over here, and this is just a bird's eye view of our solar system, and this is the actual view. Actually, this photograph is known as pale blue dot. It is the replica of the very famous Voyager photograph which Carl Sagan showed in his original Cosmos series, and this was replicated by the Cassini mission in 2013, I think. And these are the rings of Saturn, and this pale blue dot is the Earth. So just from our from a planet which is just two places from us, or the third planet from the sun, and we are not even visible as a dot. Let us travel further back, and this is our galaxy. Of course, this is an artist render of the galaxy, which is Milky Way, and the position of the sun is somewhere over here. Now, how large is our galaxy? Of course, this clouds that we see. Now, this blue portion is not the sun, but it just marks the position of the sun. The clouds that we see are actually stars. These are stars just like our sun, or maybe sometimes even hundreds or thousands of times larger than our sun. What about the distances? So, if we have a spaceship that can travel at the speed of light, and we are about to cross our galaxy from this end to this end in a diametrical fashion, then it would take our spaceship about 2 lakh years. So that is the diameter of our Milky Way galaxy, which is something around 2 lakh light years. What about the number of stars? So it is estimated that Milky Way contains about 200 to 400 billion stars. And actually, this number does not by itself seem very large. But let us imagine what does 200 to 400 billion star means. It means that if we were to gather each and every particle of sand from all the beaches of the earth, that still would come out to be a number which is less than the number of stars in our galaxy. So that is the meaning of 200 to 400 billion stars. Actually, sometimes when we deal with such conversions, it's very easy to forget what is the power of three zeros. So if somebody would come up to you that billion is nothing but three more zeros added to million, because million would be 10 raised to 6, billion would be 10 raised to 9. So there is a difference of three zeros. But let us consider how large this difference is. Suppose I was to give to you 1 million seconds. So 1 million seconds would be something about 13 days. It would be something around 13 days. 1 million seconds, 10 raised to 6 seconds would be something around 12 to 13 days. If I were to convert that to a billion seconds by adding just 3 zeros or multiplying by 1000, 1 billion seconds would be 32 years. So just imagine the difference. Million was 13 days and billion was 32 years. So that is the difference between million and billion. How thick our galaxy is. So basically galaxy, uh, which is the shape of our galaxy, which is a spiral galaxy, generally it is bulged at the center with number of stars being very large at the center of the galaxy, and it tapers out as we move outwards or as we move radially outwards. So at the center of the galaxy where the, the galactic bulge is situated, the thickness of our galaxy is about 3 to 4,000 light years. So if you were to pass through the galaxy at its center at the speed of light, it would still take you 3 to 4,000 years. So that is what are the dimensions of our galaxy. So of course, now by zooming out to this much, we do feel that we are very, very, very tiny. But wait, we've still some more to go. This is what we call the Mercurian chain. It is a chain of galaxies. I think in this picture alone, you can see about 13 odd galaxies. This all galaxies belong to something which is called the Virgo cluster. A Virgo cluster is also the parent cluster of our own Milky Way galaxy and the Andromeda galaxy, which is the nearest galaxy to us. So the bright elongated dots that you see on the picture are themselves galaxies which are similar to our own Milky Way galaxy, or sometimes they may be even larger than our Milky Way galaxy. And this is, I think, the most, uh, let us say, mind boggling picture of all time. This photograph is known as the Hubble Deep Field. It was constructed in 2013, if I remember correctly, by uh, gathering or by processing all the data that was received from the Hubble Space Telescope during the time of its operation until 2013. And actually, uh, this photograph is just an area of sky which you would cover when you extend your pinky finger to your complete arm's length, and the nail of your pinky finger, the amount of sky that the nail of your pinky finger covers, is the size of this photograph. So this is a very, very, very small part of the entire sky that is visible to us. Each and every dot in this picture is not a star, but it's a galaxy which is comparable to our Milky Way galaxy. And this photograph has about 3 to 4,000 galaxies, that too into a part of sky which is the size of your pinky finger nail, and that pinky finger is extended to your arm's length. So this is something beyond comprehension. I think uh, it makes you feel that you do not exist. The size of the universe is so large that we cannot imagine the magnitude by which we are smaller than the universe. This also produces another revelation in our mind. So first was how small we are when compared to the universe. Now let us say how recent you are. We saw that what is our size when we compare the other things in the universe. Now let us see where on the scale of universal time we are. What is our place in the timeline of the universe? Okay, this is the most agreed upon model which almost all theorists think that would be how the universe was born. So the universe was born in a big bang which was somewhere around 13.8 billion years ago. And the first stars, it was just plain energy. The first stars means energy formed matter, and the matter formed the first stars, and it was not until 400 million years from the big bang that the first stars were born. So the time period of time zero, t is equal to zero, when the big bang happened, and until the first stars appearing in the universe was 400 million years. That is sometime also known as the dark age of the dark ages of our universe, because there was no light, because there were no stars. And then from the stars we had uh, structures that were made up of stars, that is development of galaxies, planets, etc. So the only thing to remember is that the present uh, age of the universe, on which almost all scientists agree, is somewhere around 13.8 billion years. Now, this may change if we gather some new evidence. This may change because I think until 20, 25, or 50 years ago, this age was some different numbers. Uh, the science that we do, it does not falter to backtrack. It does not falter to admit that it is wrong, because we have learned something new and we expand our horizons and our definitions change. But presently, it is agreed that the universe is 13.8 billion years old. So let us do a mental experiment. Let us take the age of the universe not to be 13.8 billion years, but let us take it to be 14 billion years. And the history of this 14 billion years has been written in the 14 volumes of book which you are seeing on the screen. So we have 14 billion years of history, and we have 14 volumes of this encyclopedia which holds the history of the universe. So it is fair to say that each and every volume is going to hold 1 billion years of the history of our universe. So 14 of them together will make up the 14 billion years of the history of our universe. Fine. Now let us assume that each and every volume has 1000 pages. So all the volumes have 1000 individual pages. So if a volume is holding a history of 1 billion years, and that volume has 1000 pages, then we can safely say that each and every page of this volume is going to hold a history of 1 million years, because million multiplied by 1000, that means million years of history on one page. That multiplied by 1000, because the volume has 1000 pages, that will come to 1 billion, and that will be the content of one volume of this encyclopedia set. So each and every page is going to hold a history of 1 million years. So now, what would be the volume where humans would first appear? So actually, the hominids, that our which is our genus is supposed to be seen on this earth for the first time about 2 million years ago. So the word hominid would appear on the second last page of the last volume of this entire set of books. Just imagine all the volumes, all the pages of all the 13 volumes, and 997 pages of the last volume do not contain anything about our human race. And still further, now this is just the first hominids, which also includes Homo erectus, which also includes uh, Australopithecus. Our species, our subspecies, which is the Homo sapiens sapiens, is supposed to have evolved just 3 lakh years ago. So it is not on the last page, but almost on the last line of the last page of the last volume. Where would have sun first appeared? So the sun, which is our parent star, would have appeared in the volume number 11, not before that, because the sun is supposed to be 5 billion years old, and the earth and the other planets are supposed to be 4.5 billion years old. So this is what is something beyond our limited intellect, that we are very, 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 very recent in the scale of time when we see the time scale of our universe. So the two things that we discussed, which is how small we are as compared to the universe, and the second thing, how recent we are as compared to the universe, these both things, these are depressing facts that might hurt our ego, that we are nothing in front of the universe. Let us see something positive that the universe presents to us. We all are stardust. Now, how is that? So here we have the nuclear reaction, in which when the universe was born, it was just pure energy, and when that energy converted into matter for the first time, it might have been the simplest time of matter, which is an hydrogen atom, and the two hydrogen fuse together, they make up helium. When two helium fuse together, they produce beryllium, which is unstable, and one more helium is added to it, and we get carbon. And this thing moves on to one carbon and one helium will come up with oxygen. Oxygen and helium will come up to neon. And helium will come up to magnesium. Carbon and oxygen will combine to produce silicon. Oxygen and oxygen will combine to produce sulfur. Silicon and silicon will combine to make iron. And where do you suppose these reactions, these fusion reactions, go on? Of course, they go on in the center of the stars that we see in our galaxy. So the more complex atoms are always produced in the stars. The universe, when it was born, and the first matter that was produced was obviously hydrogen. And as hydrogen, due to the stars, due to the processes in stars, gets converted into more and more complex atoms. And when stars die, these atoms are dispersed as seeds into the universe, and at some point they will be a part of some planetary system, and which might harbor the kind of life that we have. And this life is again made up of these complex molecules or complex atoms, which were some time ago, some very large scale of time ago, part of some star. So basically, these are all the elements that make up our body, and we saw how these atoms were made in the stars, and now they are part of our bodies. So if the same atoms which were in the stars some time ago and today they form our biology, then of course we can say that we are star stuff or we are stardust. So this is a fact that would again make us a bit happy after those two depressive facts that we saw, that we are so tiny, we are so puny, and we are so recent in the scale of time. So now we come to amateur astronomy. How does a person who's not an astronomer or space scientist learn more about the universe? Of course, if you have made a career choice which is not science, which is not space science in general, and you are thus never going to become an astronomer. But knowing the facts that we have discussed above, and you feel that you are interested to learn more about universe, what can you do? Of course, you cannot revert your career and start on a new path, but you can always be an amateur astronomer. You can cultivate a hobby which is known as amateur astronomy, and you can look at the universe, be amazed by it, and also contribute to the real scientists, real astronomers, or space scientists who, of course, do not have time to do each and everything which is needed to advance astronomy or space science as such. So, anybody can be an amateur astronomer. It does not depend on what your career choice what was, or what was your major in, what was your minor subject. Because if I talk about our club, we have, of course, we have more number of engineers, but we also have doctors, we also have science graduates, we also have business people, we also have chartered accountants, we also have architects who are amateur astronomers and who are very keen amateur astronomers, we also have teachers, we also have professors. So, and that too, not the professors of the fraternity of science, maybe somebody is from literature or somebody is from some other field. So to be an amateur astronomer, you just need to be curious about the universe and the night sky. That is all you need. So if you decide to be an amateur astronomer, of course, to a lay person, the sky every day looks the same. uh, of course, every other full moon night, he might be amazed by the size of the moon, or the moon would be at a new place on every other day, its size would be different. That apart, he will always find the skies to be safe. So what is there in the night sky that an amateur astronomer looks up for? So of course, uh, we have stars and constellations that we can look up. We have planets and their satellites. The moon, of course, it's the most beautiful thing that you can look through a telescope in the night sky. And then there are the deep sky objects, the star clusters, the nebulae, the galaxies which are far, far away from our galaxy. And these are the things that would require your skills to be at a certain level to uh, see them or to observe them, to locate them. And of course, there are amateur astronomers who are interested in artificial satellites. And occasionally, there are the meteors and visitors from far, far away, which we call comets. So, now this is also a list of things that an amateur astronomer would look. And so, there are amateur astronomers in the world who would specialize in any of the above, or maybe more than one of the above topics that we have listed. So there are amateur astronomers who are just interested in photographing the moon. They take thousands and thousands of photographs of the moon. They join those photographs, which is known as stacking, and they create very beautiful, very detailed images of the moon. There are amateur astronomers who are interested in tracking artificial satellites and photographing them. This is a very difficult task to do. So there are some amateurs who are interested in photographing the ISS, that is the International Space Station. Uh, they do photograph it when it transits the moon or the sun. There are people who are just interested in deep sky objects. If I talk for myself, my uh, area of interest has always been DSOs, or deep sky objects, that is the star clusters, the nebulae, galaxies or distant galaxies. So if a person is under a very clear, very dark and moonless sky, if he looks up at the sky with his unaided eye, no optical aid being used, he is able to see some 3,000 stars in the night sky. Of course, the nights will be moonless. So if a full moon is present in this sky from that same location, which is clear, which is dark, the number of stars that he can observe decreases tenfolds. You will only be able to see about 300 to 350 stars. So that is what the moon does. So for us amateur astronomers, the moon is something which is taken as an object which produces light pollution. Of course, it's a natural object, but it still produces some light pollution of its own. And every now and then, when we want to observe the DSOs, the deep sky objects, we try to avoid the part of the night, or we try to avoid the night when the moon is quite large and present in the sky. If at this particular location, in the absence of the moon, you are able to use an instrument which is a very humble instrument, a 10 by 50 binoculars. 10 by 50 means that this instrument has a magnification of a 10, and its objective diameter is 50 millimeters or 2 inches. You can look at the image of the binocular, how small it is, just fits into your hand. The number of stars that you can see with such a humble instrument would be somewhere around 1 lakh. So you can see how many times the number of stars has increased. Sometimes some people would wonder that what is there to look in the stars. So these are some images which I have chosen to make you feel that there is much more to see in the stars than just a bright speck of lights. So the first photograph is that of a very beautiful pair of stars that we see in the winter sky. These are the two brightest stars of the zodiacal constellation of Gemini, Castor and Pollux. So these have very beautiful contrasting colors, and these colors would be visible when you take a look at them from a dark location, or else they would just appear to be white dots in the sky. The next photograph is that of a double star, which is in the constellation of Cygnus. So this star, actually, when you look at it through your naked eye, it would seem like a single star. But as soon as you point a telescope at it and pump the magnification greater than or equal to 40x, it splits into a very beautiful pair of very contrasting colors. So this star goes by the name Albireo. It is beta. It is also known as Beta Cygni, the second brightest star of the constellation of Cygnus. And these are some very beautiful constellations to see. Uh, the left bottom one is the Ursa Major, which is very famous in India as Saptarshi. And the center one is, of course, the zodiacal sign of Scorpius. And the rightmost one is one of the most beautiful constellations in the entire sky. Of course, it belongs to the winter sky, but goes by the name Orion, or we in India call it the Mrig Mandal. Then we have the motion of the sun through the zodiac. That is also a very beautiful thing to see, how the sun traverses through each of the 12 zodiac in 1 year and again returns to the same zodiac. Not go much into detail of this. You can look at the major planets now. Here I have selected the photographs of the planets, which are something you would see in our amateur grade telescopes. I would have easily got images from the Hubble Space Telescope and displayed it over here. But of course, after seeing those images, when you were to see those planets from a real amateur telescope, you would be disappointed that the slideshow had a fascinating picture of the planet Jupiter or beautiful rings of Saturn, and this planet is so very small in an amateur telescope. Of course, this is the best view that you can get from the amateur telescopes, but of course, it does present a lot of details if you are able to see them. Jupiter has its four Galilean moons around it, two on one side, two on this side. Just looking at the Jupiter day in and day out, the beautiful dance of its satellites would be visible. Sometimes you have three on one side, sometimes you have four on one side, sometimes you have only three appearing because one would be behind the planet. And this is what this view is what made Galileo think that the universe was not geocentric, means the universe did not have the earth in the center, but it might be the other way around, with sun as the center and earth with the rest of the planets going around it. Of course, when you see these smaller planets, that is Mars, Mercury, and Venus, Mars does present some sort of detail when it is very near to us. In other cases, it would be just a disk which is orange red in color. Mercury and Venus are interesting because, being inferior planets, being planets which have their orbits smaller than the orbit of the Earth, means they are inside the orbit of the Earth, they present phases just like the moon. So the two images that we are seeing on the right, that seem to be crescent moon and gibbous moon, are actually not that of the moon, but they are that of the planet Venus. And Mercury is also shown in a gibbous phase in the left side bottom image. Of course, as I said earlier, moon is one of the most beautiful things to see. Most of the people who have not been into stargazing would think that the best time to view the moon would be on a full moon night, but that is something which we would call exactly opposite of what one would like to do, because the moon would be most beautiful to see after it is half a phase, if we are in the waning fortnight of the moon, or before its half phase, where if we are talking about uh, the early part of the lunation. So before first quarter or after third quarter is the best time to see the moon, when the sunlight is falling obliquely onto it. And what this does is that the obliquely falling sunlight will create shadows of the craters and the mountains of the moon, and they will make you feel the depth in the image that otherwise would be washed out, and you will feel that the thing that you are seeing has an element of depth or has an element of height to it. So that makes up more realistic image in your brain, and that is why before first quarter or after third quarter would be the best time to see the moon. So what would be the most distant object that can be seen with your naked eye? Of course, that would be the Andromeda galaxy. Andromeda galaxy is the nearest galaxy to our Milky Way galaxy, but still, at the nearest, it has a distance of 25 lakh light years, 2.5 million light years. So if you were to see Andromeda galaxy today, of course, in this time of the year, it would not be visible. It is very good to see after September until March. So if you were to see, say for example, if you were to see the Andromeda galaxy today, just imagine that when you are seeing this galaxy, your retina is being bombarded by the photons that were emitted by the stars of the Andromeda galaxy. And these photons have been traveling in space for 25 lakh light years, 2.5 million years they have traveled. Nothing has interrupted them, and today their journey ends on the retina of your eye. Just imagine something, that a photon which left a particular star of an Andromeda galaxy, it left that galaxy, it left the star when there was not even the human race on our planet, but that photon in its destiny was going to strike a person that was going to be born in a certain on a certain planet of a certain species, which was not even born when that photon left the star of the Andromeda galaxy. So this is something amazing. But still, this is the nearest thing to our own galaxy. So just imagine what would be the farthest thing of our universe be. Andromeda Galaxy is pretty large. It appears pretty large in the sky. The angular size of Andromeda Galaxy is somewhere around 3 degrees. 3 degrees is something equivalent to 6 times full moon or 6 times the sun, because the sun and the moon both make an angle, both subtend an angle of about half a degree to our eye. So the angular size of the moon in the sky, full moon in the sky, is about half a degree. So to fill up the size of the Andromeda, you need to have 6 full moons in a line, and then that would be a size which is something equivalent to the size of the Andromeda Galaxy that it appears in our sky. Uh, there are a few photographs of some galaxies that I would like to show you. This is a beautiful pair called M81 and M82. M means the Messier catalog, and these two galaxies are in the Saptarshi or the Ursa Major constellation. The distance to these galaxies is something of the order of 12 million light years. So that is far, far away as compared even to the Andromeda galaxy. In the constellation of Leo, we have a triplet, three galaxies, so it's known as the Leo triplet. The reason why I have kept this photograph is that the distance of these galaxies is somewhere in the range of 65 million light years. So if there was an intelligent civilization on some planet of this galaxy, of some star, and a planet going around that star, they had an intelligent civilization. Of course, our rules of physics does not allow it, but if they were able to develop a technique through which they can look at the earth at optical wavelengths, and if they were to do so, they will see dinosaurs roaming on the earth, because that light, the light of 65 million years ago, would reach them today. This is again the second Leo triplet. This is also almost in the same distance range. Here is the very interesting example of the Crab Nebula. Of course, it is known as the Crab Nebula, but it is situated in the constellation of Taurus, and it is the first object of the Messier catalog, so it is also known as M1. Now, why is this object interesting? Because it was not always there. There is a very significant example stated in by the Chinese scholars that in 1058, if I remember the date correctly, in 1058 AD, that is, say, many, about 1,000 years from today, more than 1,000 years, these Chinese astronomers were able to see a star in the sky which was visible even during daylight. So this star went supernova, and it was so bright that it was visible during daytime for months. They recorded the position of the star very specifically, very accurately, and today, if we look at the location of that star, we are able to see this Crab Nebula. So in astronomical terms, the Crab Nebula is something which we call the supernova remnant, SNR. It is a remnant of a supernova. There is a central star in the nebula, but it is not visible to us at visible wavelengths. If we are to take the infrared photograph, that star would be visible, and it has been done by the Hubble Space Telescope. And this is the last discovery, which was 2 years, 3 years back. The star Erectus that is shown over here is one of the most distant stars that we have ever seen. This photograph was taken by the JWST, James Webb Space Telescope, and this star was produced when the universe was just 900 million years old. Remember, in the photograph of the Big Bang, I showed you that the first stars appeared 400 million years after the Big Bang, and this star was produced just 900 million years after the Big Bang. So it is the most distant objects that we can ever see. And of course, if this star was this far from us, we would never see it. But it is a very beautiful coincidence, a cosmic coincidence, that we have a very large group of galaxies, which is known as the cluster of galaxies, which is known as the WHL 013708. This is a cluster of galaxies. These galaxies are just in front of this star, and the gravity or the gravitational fields of this galaxy is what concentrates the light of these stars, of this star Arendelle, and it boosts the light of the star by 40,000 times. This is something which we call gravitational lensing, something like a convex lens. Convex lens concentrates light by by the principle of refraction. This actually concentrates light by the principle of bending of light due to very large gravity, so it is known as gravitational lensing. So this cluster of galaxy, the gravity of this cluster of galaxy is what made this Arendelle star visible to the JWST. And this is a very recent discovery. I think 2 years back they discovered this star, and it is by today's standard, by today's knowledge, it is the most distant objects we have ever seen. So now we come to the last part. If this much amount of interaction, or let us say information, makes you feel interested, but what next? Read, read, and read. There is no option for gaining more knowledge other than reading. Learn the night sky, and learn the night sky under the night sky. There are a lot of planetarium apps for your smartphones, for your laptops today, but they are meant to be used under the night sky by the apps by themselves. If you learn the apps, if you learn to use the app, if you can locate everything on the app, that does not make you an amateur astronomer. You have to correlate your app, the information of your app, onto the live night sky, and that would require at least a year, because you will not see all the constellation in a single season. To see all the constellation, you have to look at the sky for one entire year. Of course, this is the second part. You can download apps which make you help learn the night sky. Apps are like Stellarium, Sky Map, Sky Safari, or Star Walk. Any of the apps you can use. I personally prefer Sky Safari because it is very versatile, and it has many other advanced features which help me when I'm using Sky Safari on my telescope. But that's a different thing. Stellarium would also be that good if somebody is uh, well versed in using that software. But I myself prefer Sky Safari, but you can use any of them. All are good. You can join an existing club. If your town has an astronomy club, join it, because uh, I think if you would read for 2 3 months, that would be something equivalent to an hour or 2 hour you spend with an expert, just talking to him or her. So interaction is the best type of best method of gaining knowledge as far as this or any other field goes. Whenever possible, attend star parties near you, astronomy seminars or conferences when they are near you. Try to attend them whenever you have free time or whenever it is possible. So this would take you as far as you need to go in the field of amateur astronomy. What our club does, if a person joins our club, he can be the part of the public outreach sessions that we do. We do a lot of public outreach sessions in Rajkot, that is our home city, and in cities around our home city. So we have public conferences, we have lectures, we have seminars, and we have public observation sessions. uh, Actually, our observing season starts from 4th of October, that is the start of the International or World Space Week, 4 to 10th October. So we start our observing season from 4th of October, and it goes to 2nd of June, which 2nd of June is Zero Shadow Day for Rajkot. And then our equipments are put into hibernation for the monsoon. So this entire observing season, on every first quarter moon, we have something which we call Rajkot Sky Watch or Rajkot Moon Watch, wherein our telescopes are kept out for general public. They will come and observe the skies, whatever is visible. Moon would be there. If the planets are visible, we will show them the planets. And of course, during events like solar or lunar eclipses, we are there to show them the wonders of the night sky. We have programs for very young children, junior and young astronomer. Why I use the word very young children is due to the fact that if you take a 7 or 8 year old child, the two things that I guarantee would interest him, one would be the stars and other would be dinosaurs. So young kids are always passionate about these two things. Of course, I cannot teach anything regarding dinosaurs to them, but I can make them learn the stars. So we have been running this program since I think last 9 years, and we have trained about 700 kids from the age of 8 to 12 years old in using a telescope, navigating through the stars, using a star map, and things like that. They also make models like the sundial or the star clock and learn using them. We make sure that we do not teach them facts. We do not want to teach them how many satellites does Jupiter have, how many planets go around the sun, nothing like that. That now that information is at your fingertips. But we would like to uh, get them into this beautiful hobby. We would like to sensitize them for this beautiful hobby, or maybe it may turn out for a career for them. We arrange star parties. This also we have been doing since last 10 years. And as far as I know, we would be the first club in India who has been successfully doing multi-day star parties since 2016. So we have most of our star parties are in Gir forest, because Gir is very near to us and it has one of the most beautiful skies, dark skies in the entire country. So this is one of the uh, image montage of uh, image of the night sky, our Milky Way special give star party, and these are all the photographs that have been taken by the participants. And some of the participants have learned photographing the night sky just 2 hours prior to the photograph that this photograph that they have taken. And this is one of the most recent additions. I think this video is not playing. Okay. So this is the observatory that is on our science center campus. The campus that you saw is the building of our science center. It also houses the Big Bang Astronomy Club. And the most recent thing that we have done just a month ago is that we have purchased small 5-inch telescope, uh, and using these telescopes we are going to initiate a telescope library, wherein we will uh, teach how to use this telescope to children or maybe the parents, and then they can rent our telescopes and observe the night sky. And if they feel that they are interested to a certain extent, they can go for their own telescope. But until that, they can rent a telescope from us, and then they can observe the night sky. So I think that was it. Thank you very much for listening to me, and clear skies. uh, uh, I think if there is time, we can take one or two or maybe three, four questions from the participants.
So, thank you, Neelesh, sir, for this wonderful talk. So, let's have questions from the audience.
Hello, Neelesh sir. It was really wonderful talk and enlightening for me, and I enjoyed every slide of this talk.
Thank you very much,
Nilesh sir,
sir.
my question is from your one of the slides that you told us that the observation of Jupiter was the point of conclusion for Galileo that our solar system is not geocentric but it is heliocentric. Can you please explain this
Exactly.
part?
Yes. Okay. Sir, one thing I would request to you is that please don't call me Nilesh, sir. Just Nilesh is fine. I'm, I think, quite younger to you as far as maybe knowledge goes or experience goes, everything. So it would be just uh, it would be fine if you just call me Nilesh and no, not Nilesh, sir. Fine. So
Okay.
Galileo actually observed the dance of the satellites around Jupiter. So he made the drawings of the planet and small stars. He thought of them as stars at first, stars that are visible around it. And every day he noticed that they moved in a specific pattern. He made observation at the same time every day, and he found that there is some specific pattern to it. And from that he was able to conclude that these things which are star like things around near the planet are actually going around the planet. And if at that time it was thought that the only things that are going around the earth, so there are no orbits other than orbits of the earth. So if he thought that if these small things, these small satellites are going around the planet Jupiter, then the very complex thing that the Aristotelian or Ptolemaic system taught. Ptolemaic system stated that the geocentric system was not able to directly explain the thing of retrograde motion of Mars, specifically of Mars. So what they came up with was that it is not the planet Mars that goes around the Earth, but it is the epicenter of Mars going in epicycles around that center, and that planet is going around Earth in epicycles. So that was not a very natural way of things. That was what Galileo and even Copernicus thought. So Galileo was not happy with this complex sort of motions uh, that was written, or that was let us say thrusted into the academia by the Aristotelian and Ptolemaic scholars, that it was the earth at the center. He was not happy with it. So he thought that things should be simpler. And the example of small satellites going around Jupiter made his belief firm that it is not the earth at the center but the sun at the center. Now Copernicus was a smart fellow. What he did was that he did not publish his works. He stipulated that his work be only published after his death, so that he knew what would happen to him, what the church would do to him if he published the work which was against what the church taught the people. But Galileo, I think, was a bit naive, and in terms we can call him a bit uh, stupid, that he came up with his work and he showed his work to the public, and then he was uh, taken into custody by the church, and we all know the story. So it was this phenomenon that is noticed, and he very well documented, that made him think that it was the sun as the center.
Thank you very much, sir. Uh, interesting part or slide was that the volume of encyclopedia to find ourselves in how old we are. It was very interesting. Thank you so much.
Thank you, thank you, sir.
Yes, may I ask something?
Sure, sure, sir.
Okay, I am Dr. Aluwalia. Neelesh, your lecture was just wonderful. The pace at which you really spoke, that was so good that one could follow each and every word and every picture we enjoyed.
Thank you, sir.
And I was wondering the way you have really carried your club forward. I mean, the idea of having a library of telescopes is a wonderful idea. I think it's a very community kind of an idea. For a community, if one wants to do something, I think this is the right way to go ahead.
Thank
And the pictures which you showed, I was very happy that most of the pictures are one which you had clicked.
Yes, sir.
And I think astrophotography is emerging as a very, very important hobby with the people. Uh, they are having such devices like Sea Star telescope, with the help of which they are able to take multiple and multiple of images to create a final image with a lot of resolution in that. I think that was another wonderful thing for me. And I also realized during the discussion that the zero shadow day is different for different places and it can
Yes,
vary from during the whole year. So this can be a very interesting, small exercise which can be given to the school students that come daily and try to see that how the shadow is changing. That can be a useful project during this implementation of national education policy. People are talking a lot of activities. I think this will be a wonderful activity which can be created in a school very meaningfully. And anybody can come, not necessarily we have to have very mature student. Even a say class one student can also come and see that whether shadow is there or not. I think that will be a very interesting beginning to whole of this activity itself.
yes, sir.
And that the quantitative comparisons which you were giving during your talk, they were just wonderful. And that pinky finger comparison was just great. It was just wonderful. Uh, I am also very new to this. I live in Shimla, and Shimla sky is comparatively very, very nice to click pictures and see stars, etc. And NASNI has actually done this good thing, particularly to me, that I got interested in looking at the night sky in this fashion. Now, uh, NASNI is moving very nicely, and I would like to express my personal gratitude and the gratitude of IAPT NASNI for coming and giving a beautiful lecture. And I hope, Neelesh, you will also find time in future for NASNI's activities. Thank you.
Of course, sir. Anytime, anytime. And I would suggest that actually what we do, we have been doing from last 10, 15 years is that on both of the solstices and on both of the equinoxes and along with that on both the zero shadow days. Rajkot has two zero shadow days. It is located on at 22 degree north. So once during the northwardly उत्तरायण के वक्त एक होता है, एक दक्षिणायन की तरफ वक्त होता है. So we have that on 2nd, 3rd of June, which is due to Uttarayan, and then again due to Dakshinayan, we have the zero shadow day on 9th and 10th of July. So 9th and 10th of July, generally it is clouded out. So basically, we have to work with the 2nd and 3rd of June. So we publish a small pamphlet as such in social media and to our whole WhatsApp context that you put up a gnomon, you take a shadow at this this much time, because the local time would be different from what your watch or clock is going to show you. So at local noon, you put up a gnomon, you record the shadow and do these simple calculations, and you can work out work out your latitude on the equinox day or on the solstice day, or on the zero shadow day. You can work out the declination of the sun, what it is, because the declination of the sun would be exactly equal to your latitude on the zero shadow day. So these are small pamphlets that we have already prepared, and we publish it on the day which is coming on, and we record the answers of students, because each and every year there will be new students would be appearing in this exercise. So we ask them to take photographs, and then we publish these photographs on our social media. So they feel that they are being given a stage, and that gets them started into the experimentation.
Another thing, which I very much liked was when you talked about when to click the picture of moon. I found an artist speaking that look, when the shadow is there, you know that there is a depth, and you are creating a value in the picture itself. I think
Exactly.
that was great when you mentioned it. I think these are the small tips which are worth capturing and sharing with the students.
Yeah, of course, if you are doing astrophotography and you want to get a new picture every night of the moon, because the craters would be most visible on the terminator, the line which separates the day and night part of the moon. So the terminator is going to move away by a little bit on every other day or every simultaneous day, right? So every simultaneous day you are going to have a new range of craters appearing on the terminator, and that is something beautiful to look at, that is something beautiful to photograph.
And one can create a movie also out of it. I mean, you can have a very interesting
Exactly.
movie which will show you the movement of the Terminator and also appearance of the craters on the moon. Just great.
Yes.
So I think these are
Yes,
wonderful
sir.
tips which you have shared. Yeah, thank you very much once again.
Thank
Yes,
you, sir.
ma'am.
Thank you.
Excuse me, sir. First of all, I would like to thank you so much, Nilesh sir, for explaining wonderfully and covered all the topics, and you have beautifully covered the connection between astronomy and astrophotography.
I've lost your audio.
Whatever I have taken some screenshot from your photographs, so can I share it with my students?
Of course, I'll just forward my entire presentation to NASNI, and
Okay.
I will also share my presentation in our GSP group. કિન્નરીબેન તમને સીધું મળી જાય એવી રીતે હું PDF મોકલી આપીશ.
ઓકે અને સર આ યુટ્યુબ બી મળી જશે મને યુટ્યુબ પ્રેઝન્ટેશન સો દેટ આઈ કેન ઓલ્સો શેર ઇટ વિથ માય સ્ટુડન્ट्स
That
एंड
you
दे
would
कैन ऑल्सो ज्वाइन द ग्रुप सो दे
uh,
कैन ऑल्सो मोटिव अभी तो क्या हुआ है कि ये भी ज्वाइन कर दिया है ना मतलब गवर्नमेंट ने एनसीईआरटी बुक्स में ही ये एज अ चैप्टर्स डाल दिए हैं जो पहले निकल गए थे एंड इट इज वंडरफुल वर्क डन बाय एनसीईआरटी सो इट विल बी बेनिफिशियल टू देम
that you would have to ask Hemant sir, that if this is going to come on YouTube or not, that I don't know.
NASNI, yes, NASNI will share this link on the YouTube also and in the group also.
Let me just tell
ओके
one
सर
thing more, Himanji, that IEPT has a website which is, I think, in the chat we can give the address where you can come. And what we do is we create galleries also of some pictures. I would love to really request Neelesh ji कि कभी कोई स्पेशल इवेंट हो आप आ जाओ हमारे यहाँ पे गैलरी क्रिएट हो जाए तो आई थिंक वी हैव अबाउट 10,000 members in our IEPT. So it will have a big reach out of the various events which happen in the sky throughout the year itself. It's very special events. We would
Uh,
like to really create that kind of a library.
ओके सर
Actually, Mihir Joshi sir is here with us in the meeting. He is an a retired professor from Saurashtra University Physics Department. He was the head of the Physics Department at Saurashtra University, and he's also a committee member at our Rajkot Science Center. And he has been motivating me since last many days that please share your work with IIPT. It would be a great help to you and IIPT together. And recently, he just messaged me yesterday about sharing it on our website and sharing it with IIPT so that more and more people can appreciate our work and get into this beautiful hobby. So I'd be very glad to share our work with you. Of course, sir has sent me the Google form to join NASNI. I'll just fill it up, and as and when I'm free, I'll forward all our astro photos. It is the policy of Big Bang Astronomy Club to keep nothing copyrighted. We just keep a small name of Big Bang Astronomy Club at maybe the right hand bottom corner or the left hand bottom corner, and that's it. We do not uh, ask anyone not to share our pictures or not to use our pictures. It is in the free domain each and everywhere. We don't care because we have been clicking these pictures by learning from somebody who has kept such pictures on the internet, or maybe given a lecture on the internet, or maybe described his work on the internet. And we tend to keep this thing in the open and for the people to learn. So I'll be glad to share it. Thank you.
Okay, sir. Thank you so much.
We can see Professor Mihir also here, sir. Nice to see you here in this program. And IEPT is trying to reach out to a lot of people around in the country. You must have noticed it also in the last 3 years. We have been doing a big reach out to the stakeholders of physics. And I think astrophysics is very much at the core of the development of the physics itself as such.
Thank
So
you.
please,
Thank you,
yes.
sir. And I'm a life member of IIPT.
Yes,
And Professor J.J. Raval, astrophysicist,
yes,
is
yes.
also a trustee of our Lok Vigyan Kendra. And he's also giving a motivation to our club people. And it is very important to notice and note that two of our students, they participate at the international level event. One 11th standard boy, Megh Joshi, he participated at the workshop at Harvard University. And
Wow.
another PG student, Abhay Karia, he participated at the technical workshop at Australia for LEGO. So these are the two students, they develop their hobby from our center, and still they are giving talks and their ideas, they are sharing ideas whenever they are in the city, and they regularly are in touch with us.
If I'm recollecting correctly, Professor Rawal used to come to Himachal Pradesh and
Yeah.
move around in Shimla,
Yes,
particularly
yes,
in
yes.
Chamba. You know, he has been going a lot.
Yes.
there.
I
Yeah,
think
and
17 years back.
yes, yes, yes. His
Yes,
daughter was actually, I think, studying in
yes.
medical college in Shimla.
Yes,
That is
his
how he
daughter was.
started coming and maintained a contact. And let me tell you, very recently also, Shimla is going to have a planetarium very soon. Its building is almost done, and hopefully we'll be able to have more activities in Shimla itself.
Sir, I would like to share one experience.
Yes,
Uh,
sir.
One of our friends, he is also a member of our Lok Vigyan Kendra. He is a retired scientist of ISRO, Dr. Haresh Bhatt. He was a head of the cyber security division. When Neelesh Bhai showed some of the photographs taken with camera, particularly the galaxy and other things, he was not prepared to believe that these photos were taken with a normal camera or a mobile camera. He was suspecting that these were from the James Webb telescope or some other high definition telescopes. So the students are learning a lot, and they are also exhibiting their skill. So Neelesh Bhai is doing a commendable job, and I appreciate him.
Thank you, sir.
And I would like to request that kindly share your lecture on YouTube. So people who have missed it today, they
We
can
do.
leisurely listen to him.
We
We
do.
will share, sir. We will share recording on
Yeah.
YouTube also.
Yeah, definitely.
All the programs which are online, their videos are shown on the YouTube. They are available there.
Yes, sir.
So Mihir, you must be knowing that we are running a series of monthly lectures on quantum mechanics.
Yes, yes.
We started from Gujarat only. The
Yeah.
first set of lectures came from there itself. So I think IEBT is a great place to be in because it has got very many dimensions of various activities. There is Arun Vansal who has raised hand, for quite some time. Arun, please ask your question.
Yeah, good evening, sir.
Yeah, please.
Firstly, it was a very wonderful lecture. I am really appreciate and thankful to the Neelesh sir. Sir, I want to know how can we join the online community of Big Astronomy Club?
Please repeat your question.
Hello.
Sir, I want to know how can we join the online community of Big Bang Astronomy Club?
Yeah, sure. You can join the online community. We have a special WhatsApp group called Big Bang Astronomy Club Virtual or BBAC Virtual, in which we have lot of people who are out of town. We are not from who are not from Rajkot and who cannot attend our events in person. So we have that group called BBAC Virtual. You can I'll just share my number here. You can message me and I'll just send you the link to join that group. Uh, or you can also follow us on Facebook. You can search Big Bang Astronomy Club on Facebook and you will find us. We are most active on Facebook and Instagram. And on Instagram, you can search Big Bang Astronomy Club dot Rajkot and you will find our Instagram account also. So you can follow us on our social media. You can also join the Big Bang Astronomy Club's virtual group, in which we post all sort of things, like just I said that what activities we do on solstices, on equinoxes. You will get all those activities from there, and maybe even sometime if you attend some of our star party, we can meet in person.
Actually, sir, I am from Haryana, so it will be not possible for me to come to the offline events.
Sure. But you can join our virtual group. I'll just post
Yeah.
my number. I'll just post my number.
Okay, thank you, sir. Means a lot. Thank you.
Can I post to all? Um,
Ritesh, see any other question? Hello, Ritesh.
Yes, yes. There are no other questions in the chat box.
Okay, then we can conclude.
Sir, where can I share my number? I don't see the chat option. No. Okay.
Prakash Dey has raised the hand. Prakash, please ask your question.
Good evening, everyone. I'm from Surat. I suspect Rana sir. उनका लेक्चर बहुत अच्छा रहा. मैंने सुना पूरा. एंड हम लोग नियर बाई है. राजकोट एंड सूरत बहुत ज्यादा दूर नहीं है. तो हम लोग सूरत एस्ट्रोनॉमी क्लब चला ही रहे हैं यहाँ पर, और हम लोग एक दूसरे से सीखते रहते हैं. एंड स्टूडेंट्स काफी सारे यहाँ के स्टूडेंट्स राजकोट में जाते हैं. राजकोट से काफी लोग सूरत में आते हैं. तो आज का लेक्चर ओवरऑल बहुत अच्छा रहा. इट्स रियली वेरी गुड टू हियर राणा सर. दैट्स इट.
Thank you very much. Thank you very much, Prakash bhai. It was an honor to speaking to all of you.
Thank you. Thank you.
I
It's
cannot
privilege
find
for
the I cannot find the chat to all thing. Means the person who had asked me for the number, I'll just dictate my number. Arun Bansal, I think it was who
Yes,
Ask the
sir.
question.
Yes, sir.
Please no, I'll just dictate my number 94264 73394. That is 94264 73394. I hope you got it.
That's fine. 9-4.
Thank you very much, Ahluwalia sir and Hemant sir. It was a pleasure for me, and thank you for giving me this opportunity. And as and when you would require something like this, and you feel that I am the fit person for it, please don't hesitate to ask. I'll be very happy to participate. Thank you very much.
Thank you so much, Neelesh. You have spared
Thank
time
you, sir,
for
for the
us.
number. Thank you, sir.
And it was really very exciting and enlightening talk for everyone, even for newcomers and for we also. And hopefully we will organize more talks on different subjects from your side for the NASNI group. And once again, thank you so much. And I extend thanks to all the participants for sparing time and enjoying this talk this evening. We meet every first and third Wednesday on NASNI virtual talk, and we enjoy all such great speakers and their experiences which they have in sky gazing and observing cosmos through their eyes. And I thank you all for this session for today. Thank you very much.